So you should have the piece of paper. It's one-sided that says glass evidence notes. It has 8 questions on it. So instead of doing notes where you write down everything that's on the slides, instead, you're just going to be answering these 8 questions. So I'll kind of prompt you when those questions are coming up as we're going over things. So glass is really important in terms of evidence. You can use it to try to figure out how robberies occur. You can use it to try to figure out hit and run sorts of situations, because glass has some really important chemical characteristics that sort of differentiates it from other types of materials. So glass is what we consider an amorphous solid. An amorphous means that it doesn't maintain its shape. So glass is interesting because it is a solid, but over time, glass will change its shape. So if you look at windows that are really, really old, like windows from a house that's a couple hundred years old, you'll actually see that the bottom of the window casing, the glass is a little bit thicker because gravity pulls the glass particles down. So you can sort of see like this is the shape, sort of the crystalline structure of glass. It doesn't have that necessarily cubic structure that we would see in a lot of things like salts or other types of solids. Instead, the molecules just sort of pick a spot and they'll sort of shift themselves over time. So that's what makes it amorphous, okay? So essentially what that means is it just changes its shape over time. So that's what number 3 is on your paper. And essentially glass in its pure form, meaning it doesn't have any additions to it, is just silicon dioxide. So what you have to do for that is you have to melt those silicon dioxide particles. So silicon dioxide is essentially just sand. It's also what's used, it's what's on the covering of our TLC plates, just ground down really fine. So if you heat that up over 2000 degrees, it's going to melt. And when it melts, it's going to turn into this amorphous solid that we see. So if you look at glass that can be formed on beaches, if you have a beach that has sand on it and it gets struck by lightning, lightning will be well over 2000 degrees Celsius. So it can actually melt the sand and turn it into a big chunk of glass. But when you look at how glass is made, like glass blowers, what they're doing is they're just heating it up in a furnace over 2000 degrees. So it just needs a really high melting point. And that's going to be how glass is formed, which is number 1. It's also really hard and brittle. So what that means is it doesn't have any bend to it. So amorphous means that it changes its shape, but if you try to change that shape too quickly, it's going to crack. And you've all noticed that if you've dropped something like a glass on the floor or a test tube, it shatters pretty instantly because it doesn't have a whole lot of give in its structure and in the way that the crystals themselves form. Even though they are amorphous and they don't have a set shape, they're not going to be ideal in terms of changing that shape. So some characteristics: high melting point, really hard and brittle. So that's number 2. So when we look at types of glass, it might seem that glass is sort of like a boring substance, but it actually, we have a lot of different types of it based on the thing that we need. So what the first type we're going to look at is what is called soda lime glass. So essentially that just has lime in it, or calcium oxide or sodium carbonate. So that's what we call lime. So if you hear of like lime scale buildup, essentially it's just calcium oxide that's formed on it. So those will be found in picture frames, windows. It's a cheaper type of glass. It's not super expensive. It's also a little bit more brittle. So it breaks relatively easily. So you can break picture frame pieces of glass, windows pretty easily. Soda lime glass isn't really super expensive. It's not the greatest quality. Tempered glass is the next type we looked at, and this is what's known as safety glass. The reason being, we use it in objects where someone could potentially get hurt, things like automobile glass or shower doors or like windows that are in a store. And this glass has soda lime in it, but when it's cooled, you want to have internal stressors already sort of put into that glass molecule shape. So that way, if the glass gets hit by something, instead of breaking into huge giant shards that could hurt someone, it essentially just explodes into all these really tiny pieces, which might seem like that's not good because it's going to make a huge mess. But if you think about a car, if your windshield broke into 2 giant pieces, one of which was really sharp, it could impale you, it could be cut off a limb, could be really dangerous. So when we use auto glass, we actually use this tempered glass. So that way the glass essentially just turns into thousands of tiny pieces that might give you superficial cuts, but it's not going to be something that endangers your life like a big shard of glass, much less dangerous. We also see borosilicate glass. This is what's used in glassware. It's also known as Pyrex. So if you have any Pyrex cookware at home, it's this special type of glass. And what makes it is it just has boron put into its structure. So if you look back a couple slides ago when we saw that molecular structure of glass, boron would essentially be in all those extra spaces. And that's what allows it to be heated up really high. So we can heat up glassware that's Pyrex or this borosilicate glass much higher than we could, let's say, soda lime glass. Soda lime glass can only go up maybe a couple hundred degrees before it cracks. Borosilicate glass can go up into the many hundreds of degrees, close to 1,000 degrees. Tinted glass essentially is just regular old silicon dioxide, and we just add color to it. So if you've ever seen like a glass blower, you see them how they roll it in those different colorings. That's essentially what it is. It's used for decoration or for safety purposes. So you'll see cars having tinted glass. You'll see glassware or vases, all that kind of stuff having tinted glass. But essentially, it's simply just for decoration. It's not for anything that's necessary. And then we see the last type, which is called leaded glass. And this is what's known as crystal. So if you have any crystal at home, what it is that makes it so shiny and has really nice refractive index, or the way the light shines through it, is because it has lead oxide in it. So that's what Swarovski crystals are. Essentially, it's just glass that has lead put into its structure. So when we look at glass as forensic evidence, we'll find it at a lot of crime scenes, especially if it's like a burglary or some kind of a car situation. And it's really good for evidence because it's really easily carried away, especially when you're working with something that has tempered glass. It's very likely that you're going to have shards of that tempered glass stuck in your shoe, stuck in your clothing. So you can often find it as pieces of trace evidence. It's also very stable. So glass doesn't break down over time like we would see DNA or blood or hair or any other kind, footprints, anything like that. Essentially, it just stays the way it is. So it's really easy to test. It's easy to store. It's easy for us to collect. It's really great class evidence. And we call it class evidence because it doesn't necessarily point directly to someone who did it like DNA would, where it's exactly that person. But instead, we can narrow the field down to try to narrow things down. So when we look at it, essentially, because we're trying to eliminate people from a suspect pool, so if glass evidence matches, that's great. So when we look at that, we look at fracture matches. So when glass breaks, the edges of it, we call it fractures. And this is going to be where you look at 7 and 8, number 7 and number 8 on your paper. But with those fracture matches, essentially we can look under a microscope, which you can kind of see here, and look and see how those white lines, those stress marks, are going to match up to each other between two edges of glass. So if you take a piece of glass and crack it in half and look at it microscopically, you'll actually see identical fracture marks, or those stress lines, into the side of the glass where it's just been broken. So you can match those up, and if they match, that means it came from the same piece. So it's almost like putting together a really, really, really detailed, intricate puzzle. And the stress patterns are going to be random. So it's not going to necessarily be certain patterns based on the certain type of glass. It's essentially you just look and see if they match. And if they do, it came from the same piece. Those two pieces match together. The stress patterns and those breaks are also going to be unique. So you can't make glass break the same exact way twice. It's really hard to do. When we look at that broken glass, we're also trying to reconstruct events that are happening. So if we see that a piece of glass is broken in a specific way, we can see whether or not a window was hit from the outside into the house, or if it was something that was maybe a staged crime, was the window hit from the other direction? So based on where the glass is found and how it's broken, we can try to figure out what exactly happened, whether or not the break occurred from inside or outside. We can also identify the type of glass, whether or not it's soda lime, borosilicate, tempered glass, and that can give us an idea as to where it came from, what the origin of that glass is. So when we look at these fracture lines, what we call them are radial or concentric.